Welcome to Science Access. In today's class, we'll be talking about the electronic configuration. It's a very easy topic. So you just need to understand the order of energy level and you can answer any question in electronic configuration. Now let's quickly go through the order of energy level. Okay, so we have this order. You have to arrange this in this form. You have to learn this, how to draw this diagram. And once you're used to it, that's all. So you have 1x, 2s, 2p. Remember we have s, p, d, f. So that's the 4 thing you're going to be using: 1s, 2s, 2p, 3s, 3p, 3d, 4s. So you just arrange it this way. Now after that, this will now give you the order at which you arrange your answers. So 1s come first. You put the 1s here, followed by 2x, 2s, followed by 2p, 2p. After 2p, what is the next? 3x. This is 3x. After that, 3p, 3p, 4x, 4x. Then we are done with this place. The next, 3d, 3d. Realize that, realize that the 3d, the 4s actually come before the 3d. So, note again, 3p, 3p, 4x, 4x, before 3d, 3d, 4p, 4p. After 4p, what is next? 5x. You now have your 5x. Then after that, you now have the 4d, 5p, and 6s. So you now have 4d, 5p, and 6x. So it follows that the next one you now have f. Note that it's at this point that you introduce f. So you now have 4f, 5d, 6p, and 7s. 5d, 6p, and 7s. After that, you now have what? The 5f, 6d. So you now have 5f. You can see the 5f here. 5f. You now have what? The 6d, then 7p. After that, you have 6f, 7d. 6f, 7d, and finally f. So once you understand this and you are asked any question, you can easily answer it. So let's take this first question. You are asked, let's assume that you are asked to calculate write the electronic configuration of fluorine. This is the mass number, this is the atomic number. Remember, electronic configuration, you are actually arranging the electrons into their orbital. So in this case, we have 9 electrons. According to the rule, S take 2 electrons, P take 6 electrons, D take 10, and F take 14. So we have 9, right? Have 1 S. How many electrons does X take? 2. Next is 2x. 2x. How many electrons does S take? Another 2. So we have 9, remember. So we still have 2 plus 2 is 4. We still have 5 electrons. The next is what? 2p. 2p. So you put the remaining 5. Remember, p can actually take 6 electrons, but we only have 5 left. So this is the electronic configuration of fluorine. All right. If the fluorine atom is neutral, we'll talk about when writing the electronic configuration of ions. All right. Now let's assume that you are asked to write the electronic configuration of calcium. Calcium is mass number 40 and atomic number is what? 20. Note that the atomic number is equal to the number of electrons if the atom is neutral, if there is no charge in it. So in this case, and this case, it is neutral. So let's write, we are going to work with 20 because the mass number, the atomic number, which is the proton, number of protons is equal to the number of electrons if the atom is neutral. So the first thing, 1s, take 2, 2x, take another 2, 2p, take 6. After that, what is the next? 3s, and take what? 2. What is the next? 3p, take 6. Note that 3p takes 6. Now, how many do we have? This is 10. 2 plus 2 plus 6 is 10. Plus 2 is 12. Plus 6 is 18. So after 3p, what is the next? 4x. 4x. and the s will take what? 2. So we now have the 20 electrons are already arranged in their orbital or in their energy level. Now, let's assume that this same calcium, you are now asked to write the electronic configuration of calcium ion. This is 2 plus. This is calcium ion. Now, it's very easy. Note that if it is 2 plus, it means it has lost 2 electrons. And if you are giving any element and you are seeing a negative value, maybe fluorine -1 or oxygen -2, it means it has gained 2 electrons. So in this case, it has lost 2 electrons. Remember, the atomic number is 20, which means that the number of proton is 20. But in this case, the number of electrons is supposed to be 20. But because it has lost 2 electrons, the number of electrons is now 18. So we are going to be working with 18. Note, if it's appearing 2 plus, it has lost 2 electrons. If it's appearing 1 plus, it has lost 1 electron. What about if it's appearing -1? It means it has gained 1. Assuming if I decide to write -1, which cannot be anyway, I'll still give you another question regarding that. If I decide to write an element, for example, fluorine -1, this one will, instead of being 9, you now work with 10 because it has gained 1 electron. So let's work with this. Because it has lost 2 electrons, we'll now work with 18 instead of 20. So we'll now have 1s2, 2s2, 2p6, 3x2, 3p6. Now, if you add all the electrons, you realize that you have 18. Let's take 2 or 3 more questions before we can call it a day. Now, let's take a look at fluorine. Let's write the electronic configuration of fluorine. We have, remember, fluorine is actually 9 proton. Atomic number is 9. But because you are having this negative charge here, it means it has gained 1 electron. So instead of working with 9, we are going to work with 10. So we now have 1s2, 2x2. Now, instead of 2p5, to make it 9, you now write 2p6. This is 10, not 5. The reason is simple. It has gained 1 electron. So let's talk about oxygen. Oxygen, in this case, is in its ionized state. Atomic number is 8, mass number 16. But atomic number of proton is equal to the number of electrons, which is also 8, but it has gained 2. In this case, it will now be what? 10. So we now have 1s2, 2x2, and 2p6. So you realize that in oxygen ionic state, when it ionizes, it actually have the same number of electrons as fluorine, though their atomic number is different. Please note that they can ask you which of these actually have the same electronic configuration. You can see this and this and you realize you think they are different. They are not. It's actually the same. So let's take a look at the last one. Aluminium. Aluminium in this case have atomic number 13 and mass number 27. But 3 plus, it means that it has actually lost 3 electrons. So instead of working with 13, we are going to work with 10 because it has actually lost 3 electrons. So we now have 1s2, 2s2, and 2p6. In this case, aluminum is having the same electronic configuration or the same electron as oxygen and fluorine. So please take note of that. You can decide to write electronic configuration of any element that you can write for any atom, provided you have the right. Please note that you must understand this concept in order to be able to get this. Thank you for watching.